Hi everyone, and welcome to Diabetics for Diabetics. Today we are going to be talking about how I make homemade colloidal suspensions using very simple hardware, distilled water, and 9-volt batteries. If you're unfamiliar with colloidals, it is an aqueous solution of different metals, transition elements, what have you, suspended in water that you can apply topically, you can ingest, you can use anywhere on your body where it can be absorbed. For people with diabetes, a lot has been made about the benefits of trace minerals, things like chromium, copper, silver, and even vanadium. And while there are ways to supplement them, you can buy them online, they are bioavailable in foods. There are more concentrated ways of doing it through colloidals. So let's take a look at what the setup looks like, how it works, and actually put it together. So the first thing you'll need is copper wire. So you'll just need 2 short cuttings of insulated copper wire with, let's say maybe an inch or so of the insulation cut off the top, because we're going to need it to connect to the terminal here on the top. The wiring is connected to 2 alligator clips. You'll need 2, again, for the 2 terminals here on the lid. Now, this lid is just a really simple plastic lid. You can get it off of a supplement jar, off of peanut butter jar, what have you. And the terminals that I've made here, I drilled, I think, a 1/4 inch hole, just drill it to match the width of the bolt that you have. So I've got a washer on either side, and then on the bottom, wing nuts here to make it easier for fastening these next clips on the bottom. So you can buy these at any hardware store. These are just simple electrical clips. And on one end, I've got a little snippet of copper wiring there to connect the clippings, which will hold the metal, to the bottom of the wing nut. And then you'll need a mason jar with distilled water. You need to make sure that it doesn't have any unnecessary electrolytes or heavy metals, what have you, in the water. Distilled water works best. And then you're going to need at least 1 9-volt, possibly more, depending on the metal that you are making into a colloidal. So you've got your lid here with your washers on either side, wing nuts, and then that nut, or the top of the bolt there. So I'm going to take each of my wires here and I'm going to loop it around the bottom so I can get it underneath. You see that? It's really wrapped under and tucked underneath. I'm going to fasten this. I'll need to untie it later in order to connect the alligator clips. But for now, just while I fasten the other one, I'm going to tighten this one up so that it stays in place, okay? Just like that. So now I'll take the other one, do the same old thing. Oops. Make sure we've got a good connection. It doesn't have to be perfect. You don't need to solder it or anything like that. But you get it tucked underneath, like so. And then again, I'm going to fasten that wing nut to ensure a good connection. Okay, so there you go. You've got these alligator clips connected to the top. Now, let's go ahead and connect these guys on the inside, on the bottom. Now, you notice I've got these hooked in there as well, so I can slide them in between the washer and the wing nut. I'm gonna keep pressure on that top of the bolt just so that copper wire doesn't come out. But just a light unscrew. I'm gonna sneak this guy underneath. If I need to take more off here, I will. There you go. And now I fasten it. Oops. Oh, see there, I went ahead and squeezed it out. So tight, but not too tight. You just want to make sure that there's a good connection so that when you connect it to the battery, the charge can pass through. There we go. There we go. Perfect. Okay. Now, for the other side, the next one, same thing. Sneak that underneath. And fasten. These wing nuts and washers are all zinc plated. Stainless steel will work just as well. You just need to make sure that it's something that is conductive so that it will be able to pass the energy through it, okay? So here's the final product here. You've got the copper wire with the alligator clips fastened at the top with the tops of the bolts. You've got the wing nuts at the bottom connecting here. And now let's go ahead and get these into the mason jar. You've got your headpiece set up. Now you need to choose which metal you want. You can use whatever you'd like. So you can do silver, you can do copper, little copper wire. You can also order specific elemental metals that you'd like to make colloidals of. I have vanadium here. I also have chromium here. Anything works, but all you're gonna do is you're gonna take whatever piece of metal it is. I'll do the vanadium here. And what you'll do with these alligator clips, squeeze them, get it fastened in there, and then fastened in here as well, okay? So now you'll have your mason jar that you are going to drop the head in. Now this one doesn't have quite enough water. You want to make sure that both tips of the metal, at least the tip, you can see here where I've done it before with this metal, you need both tips of the metal to be submerged in the water. You want to make sure that you don't have the clip itself in the water, just the metals, all right? So what you'll do is you'll put it into the mason jar like this, up to a point where the tips, or however much you need, is submerged without getting the clip submerged. So now that we've got the mason jar with distilled water filled as high as I can, keeping the metal tips submerged but not the clips themselves, now we need to connect to a power source. So the way a colloidal works is it takes an electric current and it uses each of the terminals of the metals, which are submerged in water, to connect the system. And as energy flows from one tip to the next, the metal itself is being dissolved, for lack of a better word, into the water. So in connecting the circuit, that electricity, which is coming from 9-volt batteries in this scenario, that current is being brought through the water to the other end and taking apart the one terminal so that the whatever element you're using, copper, silver, vanadium, chromium, is being dissolved in very small particles into the water. So once I've got this submerged like this, now what I'm going to do is I'm going to connect it to a 9-volt battery. Now, these 9-volt batteries I bought are rechargeable. I like them better because I don't have to keep rebuying every time I use them. Now, if you were to just buy a standard, like regular 9-volt, you'd be able to get a good amount of colloidals, depending on how long you run it, off of one battery. That being said, I just don't want to have to run back to the store to keep buying them every time I make them. So I just recharge them after I use them. Now, In terms of what you want the voltage to be is going to be dependent on the metal that you're using. Now, there are softer metals and there are harder metals. So you'll see for metals like silver and copper, you don't need a high voltage for those. And, you know, a standard 12 volt outlet, 12 volt, you know, charge is going to be enough to complete that circuit and dissolve the metal into the water. For something a little bit harder and heavier, like chromium and vanadium, you're going to need a higher voltage. When I do them, I use 27 volts. So I have a 9 volt, and I'll do 3 of them together. And I'll show you how I put them together and connect them to the terminals. And so you may be thinking to yourself, Bowie, well, okay, if you're going to use 3 batteries and I only have 2 alligator clips, how is this going to work? So what you can do now is you can see that each of these has basically like an A and a B port. And what you can do is you can connect them in series to go from 9 volts, 18 volts, to 27 volts, okay? And you still have each of the terminals available for your alligator clips. Now, just for safety's sake, and so that I don't have to worry about them coming disconnected, what I'll do is I'll take some Scotch tape here, oops, and I will fasten them together. That way, I don't have to worry about them coming undone. We'll connect them here, like this, and then one more on each side. Okay, so now it's kind of one solid piece. I don't have to worry about it coming undone or anything like that. Now, let's go ahead and get these hooked up to the alligator clips and start the colloidal. All right, so now all we'll need to do is we'll take each side of the battery, and we've got each of our alligator clips. So we're going to take one alligator clip, connect it to this terminal. I'm going to take this alligator clip and connect it to this terminal. And I may need to prop it up on something. That's all right. So I'm going to go here, connect it here, just like that. And again, we're really just concerned with that it's connected, and then we'll connect it here, okay? And so now you've got that circuit completed, and you should, depending on how hard the metal it is, it may take a few minutes, but what you'll be able to see is you'll be able to see one of the submerged ends of the metal start to bubble and fizz as that circuit is completed and the metal starts to dissolve into the water. And here's a little tip. So if after a few minutes up to an hour, you still don't see anything showing in the water, it may have to do with the pH of the water. And one tool you can use with that is baking soda. So I'm gonna take a pinch of this, just a really small amount, and put it in the water, and we'll see if that makes a difference. And so here we are 12 hours later with the baking soda added into the water, dissolved. That helped the vanadium ionize better in the water. And you can obviously see it is pitch black. Now the question comes up, how long do you want to leave it hooked up to the battery? And that is up to you and how strong you want the concentration to be of the liquid. Now, if you leave it long enough, you may start to, especially with the softer metals like copper and silver, you'll actually start to see particulates settle at the bottom. Now, that is not our goal. The power of a colloidal is in the suspended ions of the metal or the element in the water, not necessarily the particulates at the bottom. So you want that water to stay that consistent color without having all of that stuff settle to the bottom. I usually go somewhere between, for some of the harder metals, probably 12 to 18 hours. Some of the softer metals, really no more than 5 to 6 hours. You'll really start to see it start to settle at the bottom, and I know that that's enough after that. So that's it. How to set up the colloidals. You've got your batteries, you've got your alligator clips, and the elements suspended in water. Add baking soda if you need to balance the pH enough that you're creating that current between the two terminals, and sit around and wait and let it rip. All right, so thanks for tuning in. Chromium, vanadium, copper, silver, you could do them with any element that you can get your hands on. It's a cool way to use these metals.